So next up, we've got our engineer, Tom Ballestero, who's a professor of civil and environmental engineering at the University of New Hampshire. So continuing the theme of connecting ecology and engineering.
Thanks, Lynn. Well, I'm here to talk about design and stay within my time limit. Dave did a great job, and so did Corey beforehand, and I'm going to repeat some of the same themes, and some of the others I'll just expound upon. But again, these systems are completely different. From an engineering viewpoint, if you think of traditional infrastructure like a bridge or a road, something that is a structure that doesn't necessarily have to think too much about living organisms other than just surviving the environment they're put in. In this case, it's almost the complete opposite. Trying to design something and really hand it over to Mother Nature and say, we did the best we could. And then Mother Nature takes its shot. And that's what always happens. Mother Nature bats last, and you have to always respect that. And that will be a point I'll bring up again, but Dave was just talking about inspection and maintenance. Living systems, whether it's stream restoration, stormwater systems, or here living shorelines, take a lot of tender care, just like your house plant or your garden plants. So as far as the design process, this is pretty similar to engineering projects in general. Defining the problem. So very often what's been identified here today for the living shorelines is erosion. But the next aspect, defining the objective, is one that you always have to keep in the forefront. And obviously in the academic environment, when I see the students all the time, they'll come into my office, whether it's on their class projects or their senior design projects. And the first question I invariably always ask them is, what's your objective? Because it's hard to keep proposing solutions when you forget what your objective is. And the reality is you can certainly have this spectrum of the genesis of your objective. It can change with time, but you always have to remember what that is, because at the end of the day, the final project has to meet that. Once you have those first two, the problem and the objective, there's a lot of ways to solve problems. And actually, it's even more so with the living shoreline or restoration types of activities than it is with hard infrastructure. There are just so many different facets and components you can include that you'll have a lot of different concepts. And then it's all about whittling them down and getting to what's the one you're going to run with. And even at that point, you can certainly have modifications. So like the groups doing their presentations today, they got to a certain step. It's not the final design, but it's pretty much along the way that it's got all the objectives and problems being addressed. And then the last step, again, is one of the most important. You learn from every one of your projects. Every little projects have things that you would have done differently if you had to do it over again. And then what we typically fail on many projects that are built in the natural environment, whether it's a road or a living shoreline, is monitoring post-construction. Rarely do you have the funding or the ability to look at the long-term aspects of what we've done and maybe do some adaptive management. So in developing the design concepts, one of the previous slides, as Dave identified, what you're trying to do are look at the different site characteristics. For example, waves. That's just one characteristic. There's many of them, but I can continue that through this particular slide. And then with any site, you always have constraints. And some of those constraints are physical, some of those are regulatory, some of those are biological. As Dave was identifying, you have a certain elevation, and below that elevation, you really can't grow the salt marsh grasses. There may be other things that occupy those lower elevations, but they may not help with the design objective. Stop erosion. So once you get down to the design focus, three principal ways of dealing with these environments is, for example, counteract the site characteristic. Again, a wave, armor, just put in something big enough that the wave can't move it. That's a very common solution. But again, you don't have a lot of habitat value with that. The next one is accommodate the site characteristics. In that case, if you're looking at the waves, You could try to allow that wave to come, but you would have a site, for example, vegetation that will allow that wave to pass over it without disrupting the marsh anymore. Or the last one, modify the site characteristics. In front of a living shoreline, you could put a submerged breakwater. So you're actually modifying the wave attack before it even gets to your shoreline. So there's with every different site characteristic, you can look at those three possibilities. And when, again, you look at everything that's going on at the site, that's why you have so many different types of solutions that are possible. And then the last two are really interesting. We were just discussing a project yesterday, looking at tidal culvert and sea level rise. And we could put in a one size culvert and it would last fine for 70 years. But at the end of the century, there's going to be issues. A lot of our infrastructure doesn't last 70 years. Think about it. So if this is public funds, is it better to minimize the capital costs now and just realize when everything gets rebuilt in the future, that's when we'll fully size this particular culvert. In the case of the living shorelines, as Dave identified, if you're going to be building this project, are you doing it for just the very near short term, or do you have a project that will actually have a continuum long into the future? We do have challenges. Dave mentioned some of these. We had some people from North Carolina come up to the Wagon Hill farm before we ever built it. And the first thing they were amazed at was, one, the tidal range. Down where they were from, the tidal range was just a foot or two, maybe 2 feet. But also their growing season is maybe 8 or 9 months long. We don't have that luxury. And so, as Dave mentioned, green infrastructure is weakest the day it's built. And it could take 5 to 10 years for a site to actually be mature enough that it's meeting all the objectives. Dave showed this slide before, and see, I put my citations on there. Again, when you're designing these sites, these are some of the constraints. So launching into Wagon Hill, as Dave said, you'll be seeing a bunch of this. I'll go back and forth on this slide. So this is from 1992. And if you just look at the shoreline, this is where the restoration occurred. But I'll go back and forth because the same issues are happening all around this site. So this will fold into 2015. And what you see is that there's about a 30-foot loss of shoreline in that amount of time. So again, let me see if I can go back. And again, you can just focus on some of these spots, but the shoreline is retreating almost at the rate of a foot a year. That's obvious. And one of the aspects, and Dave had also mentioned this, when you have a vertical face of soil in an aquatic environment, that is a magnet for hydraulic attack, erosion. And the steeper and taller it becomes, the erosion just becomes more and more aggressive. And so that's what we're definitely seeing here and many, many other places along the Great Bay. And you can see the erosion happening every tidal cycle. It's relentless. A lot of our shoreline has the peat, which has the plant roots in it, and it's very resistant to erosion. But below that is an incredibly soft clay. So classically, what you see along the Great Bay is undercutting, collapse, and then either rafting out of the collapsed material or just wave attack, bringing that material out into the Great Bay, and then the process starts over again. So many of you had the joy of putting in erosion pins. And again, we did measure the erosion rates at Wagon Hill. This was a well we put in. The shoreline used to be out here. We put that well in 2000. And when we went out there in the, I think this was maybe 2017 or 2018 when we took this picture, that well was completely exposed. So there'd been more than a foot of erosion. And you can see how steep this bank is, and the salt marsh is completely gone. So in this case, on that western shore of Wagon Hill, that shoreline is resulting with tree loss. So there's a significant amount of issues that are being exacerbated by just the fact of the erosion happening. Again, it just seems to accelerate the time. So again, the concepts, one of the things we could do, and it may be hard to see, but up here is the existing shoreline. And this is vertically exaggerated. So that's where the erosion scarp is. And one solution is, well, let's just fill it in and have a nice gradual slope out into the mudflats. And that would require about 3,300 cubic yards of fill just along the 200 feet that we modified. And in this case, this is what you'd be doing, putting in fill. And one thing I want to stress, and I hope I bring it up again later, is all of the restorations you're involved with, again, streams, stormwater, living shorelines, are a trade-off in resources, trade-off in environments. So in this case, this was a mud flat. It was minding its own business. It was fine. Now you're going to fill it in. Why? So that maybe you can grow. Remember, we have this physical limit where we can only grow salt marsh grasses above a certain elevation. So there's no way we can protect that fill below there, unless of course we put in armor. So again, we can't grow anything to the right of that vertical line. We can only grow to the left. And so instead, what we did was put in a hard edge. That's where the rock was, or the rock with the root rods. And we have 1/3 of the amount of fill. So again, it's always a trade-off and a balance. And this is where discussions with regulatory community, discussions with the client about what might be the best way to go. How did we select that distance? It was on the previous slide. We knew where the shoreline was 30 years ago. And if we had better aerial photography, we could probably show that it was actually much further out. But again, we had some justification for this. So again, we developed concepts, and these were we spent 3 years in dozens of meetings going all over these. And a lot of times they were circular arguments. But for example, we looked at putting submerged breakwaters in there. We had core logs as one of the leading edges to protect. We used some root wads, just root wads, the crib walls, and then just using hard armor rock in this case. So again, these were just concepts that we turned into plans, and we had profiles for each one of them. We could see where these different elevations were, and therefore what we could and couldn't grow. I know these may be hard to see, but again, for each of the 4 types of edges I described in the previous slides, we had concept drawings for them. And then we could also look how they would react in sea level rise scenarios. So the final design, and I know you've seen this slide a bunch. One is we have this cuspate feature, and you see this a lot in natural environmental settings. Typically, what a feature like this does is disperse the wave energy. Whether or not the rock is there, just the shape disperses wave energy, and it tends to focus wave energy at points. This is the existing pier, but you can almost see that cuspate shape elsewhere along the shoreline. It's a natural feature. Most shorelines are a symphony between the hydraulic and the sediment and the vegetation. And they've been doing fine for hundreds and thousands of years. And then we sort of step in the middle of that and we disrupt it. Sometimes the disruption's so small, it doesn't cause a problem. Other cases, if you look along the New England coast from Long Island up to Massachusetts, you put in breakwaters to stop the erosion. That disrupts the literal cell of sediment and it just moves the erosion somewhere else where you don't have breakwaters. And we successively just put in more and more breakwaters because we chase the problem. We put in the habitat boulders on the top to break up the ice. And also you will see birds sit on those looking for food. We eliminated the best we could the herbivory from the snails and or the geese. I think the dogs at the site keep the geese away. The fence was there to keep people from trampling over the marsh. That was a huge issue with the previous site. We put in a viewing access because again, one of the key aspects of this site and many of the shoreline sites is just the visual aesthetics. People like to look at the water. And one concept, and which is nice at Wagon Wheel Farm is, again, by mid-century, this is where the edge of the vegetation is projected to be. This is where the mean tide is. And then at the end of the century, I won't be here to see it, but again, this is all migrating. And all of this is now submerged. So that's possibly all new salt marsh in the long-term future. So to finish up, I haven't seen my 5 minutes yet, but that's okay. To finish up, 1 minute. No, I said 5 minutes. Inspection's really important for these projects, and that's true of great infrastructure as well. Maintenance. You learn from all these projects. The first alternate floor we had come in there did not survive. It didn't. It wasn't really viable from the day we put it in. So we replaced it. We replanted 10,000 plugs. Where the high tide brings in floating debris, rack in this case, that's right at the high tide line, which is where the high marsh is, which is a very thin zone. It's only within about a half a foot to a foot. And when you have the rack sitting on top of the plants, it's like putting compost right on top of your garden plants. Nothing grows. And so we did some replanting, and we also had to painfully wait for them to slowly come back. We do see erosion at the sill, and in that erosion, what we've been doing is wrapping up some of the rack in core burritos and just stuffing it in there, and that seems to do the job with arresting erosion. And rilling in the tidal buffer zone, what was done was to put down a geosynthetic and then put chipped bark mulch on top of it, and that still gets some rilling, and all that's done for that is to rake it out. So essentials, I think you can see through all of these, but I think the most important essential is the communication. Again, we had a lot of meetings on this, and adaptive management if you're going to be taking some tidbits back from this. So with that, I will leave you to Q&A and another quote from Rachel.
We do have a couple of questions in the
That's
in the
not
chat.
fair. Yes.
So the first one from Taylor Bell: when reviewing living shoreline designs, permit reviewers may have difficulty deciding whether the project purpose is restoration or if the purpose is more environmentally friendly approach to stabilizing the immediate area. How would you characterize one from the other?
Yeah, that's actually a question we debate all the time, and I'm not a regulator, and so maybe Kevin can address that later. But from my perspective, again, if you put in a wall and one shrub in it, I wouldn't call that a living shoreline. And so I think the key facets which would distinguish a living shoreline from just protection is having the most significant component being the ecosystem.
Another question, at Wagon Hill, how much of the shoreline erosion is interpreted as quote unquote natural, and how much has a human catalyst? What are the human influences at Wagon Hill other than foot traffic?
Yeah, that's probably a thesis or a dissertation, but it's really hard to distinguish what's natural from what isn't, because now with climate change on there, that's a big stressor. Head of tide dams starved a lot of these systems of sediment. And so the head of tide dams could have certainly initiated the fact that the system's looking for more sediment, and where it looks is either at the fringes or at the bed itself. And then, the natural part of it, and Dave measured some of this as well. The fact that the trees that were really small 150 years ago are now so large, they cast a lot of shade on the marsh. And without the light, as Dave indicated, they needed water, light, and nutrients. Without the light, the marsh was just dying away. And so limbing trees, the bottom 20 or 30 feet, will allow a lot of light to get onto the marsh. And so those were natural aspects.
And one other, curious why the initial mortality of the Spartina ultimiflora, was it the condition of the plants or timing of the planting? This person has had mixed success depending on the condition of the plants.
Yeah, so the client wanted basically a healthy living marsh from day one. And so what we tried on this project was to put in turf. So we had a grower grow the salt marsh, the alterniflora and the patens. It was grown up in Maine, and they basically kind of grew it in ditches. And in those ditches, Spartina is a grass. I am not a biologist. want to remind you of that. So if I misspeak about biology, blame Dave because he taught me everything. You can grow this in fresh water, which was what was done. And so two things happened. One, over the winter, these swales were filled with water that froze, which probably did not allow a lot to survive. And then the second thing is they should have been brought into a saltwater diet, that is acclimate, before they dug them up and transferred them to us. So they were grown in trays. And so when they came to us, you know, it looked like you had the above ground dead vegetation, and which would be normal, and then the root structure, but after planting it, nothing really came back. Am I getting the hook? Yeah, I'm getting the hook from both ladies.
Yeah, I think we
Thank you.
should transition. Thank you, Tom.